Okay, so explain how carbon-14 isotopes allow certain archaeological artifacts to be dated. So this here is your answer. So live organisms have a constant ratio of carbon-14. So if you take an animal that's alive, for example, and you were to take a sample, so let's say alive and dead. So when the animal is alive, or when the tree, for example, or plant, or whatever it is that you're dating, might be a bone, for example, from an animal. Well, if you were to take an animal when it's alive and you were to, let's say, count the number of carbon 14 atoms that are present in relationship to the number of other carbon isotopes that are present. So, for example, just as a very, very simple example, let's say in a live animal, there might be, let's say, one, two, three, four, there might be 5 carbon 14s, and there might be, let's say, 5 carbon 12s. So they form a ratio, and that ratio, while the animal is alive, it stays constant. Now remember, these carbon 14s are going to be constantly decaying because they're unstable nuclei, and as a result of that, they'll be breaking down, and all the time. Whereas the carbon 12, this will just remain constant. Now, when the animal dies, so let's say when the animal dies, what's going to happen is your carbon 12 is going to just stay there, stay the same. So 1, 2, 3, 4, 5. Okay, but the carbon 14, so this is the carbon 12, the carbon 14, because it's radioactive, it's going to start over time, it's going to start to break down. So what happens is it has a half-life of 5,700 years, so 5,730 years. So what does that mean? So it means that if you start off with, let's say, 5 carbon 14s, 1, 2, 3, 4, 5, after 5,700 years, there'll only be half of this amount. So you'll have, let's say, 1, 2, you'll have 2.5, let's say, carbon 14s. So you can use this as a way to date a particular object. So what will happen is, if you come along, let's say, and you find this bone. So let's say this is a bone, there's some archaeological dig, and you take a sample of this, and then in your sample you find out that, so you have carbon 12 and carbon 14. You can look at this and you can say, okay, so I've done a sample, I can see that there's only, let's say, 2.5 carbon 14 atoms present within this sample. And what you can do is you can compare that to a living animal, and in a living animal it should have a ratio of 5 carbon 12s to 5 carbon 14s. But if you see here that it has the 5 carbon 12s, but it only has 2.5 carbon 14s, you can estimate and say that, okay, well, it takes 5,730 years for 5 carbon 14s to change to 2.5 carbon 14s, so therefore this bone must be 5,730 years. So as time goes on, as an object that contains carbon, as time passes, the amount of carbon 14 reduces because it's just spontaneously breaking down and decaying as per the decay, like as per the radioactive, because it's a radioactive, its nuclei is unstable and it just spontaneously breaks down carbon 14. So this is really like in a nutshell is the process, let's say, of carbon 14 dating. So by comparing the ratio of carbon 14 in the sample and comparing it to the ratio of carbon 14 from a living sample, it can be dated. Older artifacts will contain less carbon 14 than younger artifacts. So that's kind of just a very quick and very high level explanation of how carbon 14 dating actually works. So hopefully that makes sense.